Greetings, I am Andreah Faye Lapinid.
And I'm Adelaiynne Geromo. The presenters would like to introduce the thesis proposal entitled Detection of Microplastics in Metro Manila, a focus on skin contact exposure at Lumentree Jeepney Terminal. Plastics have revolutionized the way people live, work, and interact with the environment. With the single use of plastic products, most of us did not consider the repercussions of plastics. After some time, degradation processes and other internal and external stresses caused the formation of small plastic particles called microplastics. Leva 2021 stated that microplastics are less than 5 millimeters in size and can be formed into fibers, fragments, films, and others. Some recent studies mentioned that humans can accumulate microplastics through inhalation and dermal contact. Through this, the study aims to detect the presence of microplastics in the air via dermal contact with people who regularly pass through the streets of Metro Manila and characterize the type of plastics present. The significance of the study is to align with UN Sustainable Development Goals or SDGs by addressing SDGs 3, 12, and 15, specifically focusing on airborne microplastics in the Philippines. It aims to raise awareness about microplastics, their environmental transport, and potential threats to provide insights for policymakers to mitigate microplastics impacts. The presenters considered Lumentree Metro Manila as the location of the study, and the participants were jeepney drivers with at least two route rotations, starting from Lumentree to Baclaran or vice versa. 10 random drivers each day were chosen for dermal swabbing, particularly neck and face areas. This was done for 4 days. The real-time air quality index was monitored on the sampling day for the possible factors that can affect the presence of airborne microplastics. Additionally, the methodologies of some studies were used as a foundation for pre-treatment procedures since they deal with the human skin samples. Finally, the health implications of microplastics were not considered in this study.
Now for the methodology, we begin with the sample sourcing. So the participants considered for this study were the jeepney drivers who completed at least 2 cycles of the routes and those who have not been wearing cover-ups on their faces and necks. After each swabbing, each cotton tip applicator was wrapped in aluminum foil and then kept and stored in their respective seal bags. The sample preparation began by washing and submerging the swabs into the Erlenmeyer flask filled with 30 ml of 30% hydrogen peroxide. Next, the filtration. We have a system set up with a Wattman grade 42 filtered paper. This filter paper has a particle size retention of 2.5 micrometer. And the 30 ml solutions from here were filtered out in this system. And next, the swabs were washed again with 10 ml distilled water. And then the system was then left again for additional 30 minutes. Next, for the storing, each of the filter paper was stored and labeled in their respective petri dishes. And for the drying, this was done in an oven at 105 degrees Celsius for 30 minutes. And lastly, to further protect the samples from additional moisture and any dust, the samples were kept and stored in a desiccator for more than 40 hours.
To analyze microplastics, a square cut from each filtered sample was mounted on microscope slides and observed under a Leica compound light microscope to identify potential microplastics based on size and features. The sample with the most microplastics was further analyzed using a scanning electron microscope or SEM. SEM observations at magnifications of at least 40 times provided detailed surface morphology and topography. Filtered paper samples with the highest potential for microplastics were analyzed using a Perkin-Elmer Spectrum 100 Fourier transform infrared spectroscopy. This process validated and characterized microplastics by capturing a spectra in the infrared range of 4,000 to 600 per centimeter.
Another important methodology observed by the researchers was the quality control and assurance. So first, the swabs were wrapped in aluminum foil before storing them to the seal bag. Second, non-plastic laboratory equipment were used. And third, these equipment were cleaned 3 times with distilled water. And lastly, laboratory gowns and gloves were worn all throughout the experiment. Now we head on to the results and discussion. First, we have the preliminary data for sampling. Table 1, we have here the jeepney routes data collection summary by date and time. So we have our sampling date here, and here are the lists or the number of routes of each jeepney driver. Next, we have our table 2, the weekly AQI measurements and prior days data. This data was obtained from Bloom Labs, and we have here the sampling date with the respective AQI on the sampling date. Last, we have the table 3, the weather conditions during sample collection. So for each sampling date, we recorded the temperature, humidity, wind speed, and the atmospheric pressure.
Potential microplastics from the face and neck of participants were identified by their vivid colors like blue, red, yellow, and morphological features like fibers, fragments, granules, and pellets. Fiber was the most common type of microplastics, often linked to synthetic textiles, packaging, and ropes. Sizes range from 2 micrometers or granules to 750 micrometers for fibers, with measurements taken using a stage micrometer slide. The characteristic of microplastics observed, such as vivid colors and thread-like or granulated shapes, align with past studies where blue, black, red, and transparent microplastics were commonly found. These findings support the identification of observed particles as microplastics. The results highlight the diverse forms and widespread presence of microplastics in the environment, contributing to ongoing research on airborne microplastics.
Then we have the occurrence and abundance of possible microplastics. The bar graph here shows the quantity and distribution of microplastics found in face and neck samples for 4 weeks. The number of the possible microplastics were manually counted, so we have here from day 1 a total of 34 counts, in day 2 a total of 39 counts. And on day 3, we can observe the most number of possible microplastics, a total of 62 counts of possible microplastics. This was followed on day 4 with a total of 49 counts of possible microplastics. Heading on to the relation to AQI, now microplastics are regarded as the new air pollutant. They label as the PM2.5. In March 2024, a study by Wang and colleagues, total suspended particles PM10 and PM2.5 were measured in Anyang, China. This was done during the periods of fair, mildly polluted, and severely polluted air quality. They concluded that when the air quality declined, the average microplastic abundance in samples increased. And in comparison to their finding, we have here from Table 1, the highest AQI recorded was on day 4 with 28, and on day 3, we have 27. However, most of the suspected microplastics were found on day 3, followed by day 4. There is a slight difference in the count of microplastics. However, it is also to be noted that there is only a minimal difference in the AQIs. Still, it can be observed that the higher the AQI, the more microplastics were counted. Now in relation to the number of routes. The more number of routes, the longer they were exposed to the air in Metro Manila. We have here exerted from Table 1 the total number of routes per sampling day. And this may explain the great number of counts from day 3. However, the same relation is not found from the other days. And the differences may be due to the transport and different deposition rate per sampling day. The deposition rate can be affected by various weather conditions such as the wind speed. Smaller and lighter microplastics can travel great distances, and this may cause a lesser abundance of microplastics in a localized region. So, in relation to wind speed, we have here the data excerpted from Table 3. On day 1, we had 11.5 miles per hour, and on day 3, we had 9.21 miles per hour. And this could explain the difference and the low count of observed and suspected microplastics in day 1 and the opposite on day 3. Though from the set of data alone, there is no concluded direct correlation between the wind speed and the abundance of microplastics. However, the wind speed can be one of the factors that affect the deposition rate of microplastics. Then, with abundance in face and neck, most of the possible microplastics were found from the face samples, with a total of 104 items, and 80 items from the neck. The occurrence of microplastics in both areas can be supported by the fact that the skin is a receptor. Such receptor allows microplastics from a variety of sources to be gathered passively over time. A study in 2021 by Adelaiynne and Turner found out that for over 24 hours, facial and skin samples reported the second highest source of microplastics. Lastly, in relation to humidity and temperature, there have only been a few studies considering both humidities and the abundance of microplastics. One was from the same study in 2021 by Adelaiynne and Turner, where they reported the highest level of humidity to be in Bushehr, Iran. It is also the same place where they found the highest count of microplastics. They reported that the high count of microplastics can be correlated to its more humid environment, as it encourages the microplastics to adhere more to the human receptors. However, the same is not observed from the findings of this study. On the contrary, for the relation with temperature, there is a slight relation observed, as on day 3 with the highest count of possible microplastics, it reported the second highest temperature at 32.22 degrees Celsius. And on the lowest, from day 1, it reported the lowest temperature of 28.89 degrees Celsius. Now, both the findings of the humidity and temperature in this study can be related to a study in 2023 by Lim Sirong and Winishko. They found that the abundance of microplastics and temperature had a weak positive correlation, and then a small negative correlation with humidity, and a considerably smaller negative correlation with pressure. In further categorization of the possible microplastics, the suspected microplastics were grouped based on the sample sources, sizes, shapes, and colors. First, we have here the size distribution. So we can observe here that the largest percentage of microplastic sizes were reported at less than 100 micrometer. This might be indicative of the fragments of larger plastic debris broken over time. And these findings are in line with a study from Adelaiynne and Turner in 2021. From their face and hand skin samples, they found out that 60% of the microplastics were less than 100 micrometers, and only a less than of 20% were from larger larger particles. And it can also be observed that with the increasing size range, there is a decreasing count of MPs. And this is the same pattern that has been noticed from the previous studies on microplastics. Next, we have the shape distribution. So we can observe here that the most prevalent ones are fibers and fragments. There are also presence of films, granules, and pellets. And these findings are consistent with Su and colleagues in 2020. From the roadside areas in Australia, they found majority of their microplastics to be fibers, making up 45.7 to 100% of all the microplastics extracted from each location. This was followed by fragments with 0 to 45.7%. Lastly, we have the color distribution. So as you can observe here from both samples, most colors were red and blue. Other colors were green, yellow, orange, transparent, and black. And these findings correspond with studies from Zhang and colleagues in 2020 and Hidalgo Ruz and colleagues in 2012, where they predominantly found mostly blue and red fibers and fragments in blue, red, and other colors. So the differences in abundance, sizes, shapes, and colors can depend on varying factors. They may be due to environmental conditions, they could be sources from furnishings or clothing.
SEM images of microplastics revealed fibers with flat thread-like structures consistent with synthetic textile origins measuring 170 to 200 micrometers, well within the size range for microplastics. These fibrous microplastics displayed smooth area surface degradations like cracks and chaotic distributions, distinguishing them from the densely packed, porous, and orderly interlaced cellulose fibers of Wattman grade 42 filter paper. The SCM findings align with documented characteristics of polyamide or PA fibers, which further validated the identification of microplastics in the samples.
Now for the characterization using FTIR. First, they have the comparison on filter paper. So as observed, they have similar peaks at around 3,400 to 3,200, then to 2,800, and around 1,300, and lastly to 1,000 per centimeter peaks. The researchers have focused on the following ranges, and these ranges of the peaks are the FTIR assignments for the different types of microplastics. Now we have here the results. These are samples taken randomly from our suspected microplastics, and we have here in figure A with 5 significant peaks at 3,271, 2,899, 2,341, 1,319, and 1,046 per centimeter. And from figure B, we also have 5 different peaks at 3,336, 2,899, 2,174, 1,320, and 1,049 per centimeter. Now we compare this to the available table of FTIR characteristic peak assignments. They closely correspond to polypropylene and polyamide, but mostly on PA due to the peaks at greater than 3,000 per centimeter. To further compare our results, we have an image here from Williams and colleagues in 2023 of IR spectra of polypropylene and of polyamide, and as observed, there are similar peaks on a few ranges at 3,500 to 3,300, and at 3,000 to 2,800, and at 1,820 to 1,680, and lastly at around 1,000 per centimeter. We can also observe from the results that there is a peak at around 2,300 to 2,000 per centimeter that have not been reported in the previous studies mentioned. However, a study from Coupler and co-authors in 2016 have reported on the spectral range. A reference polyacrylonitrile or PAN was reported, and it matches the significant bonds around 3,000 to 2,800, and for 2,350 to 2,250, and for the bands around 1,500 to 1,000 per centimeter. And furthermore, this was compared again to the table 4 for nitride, and these corresponds at the peak around 2,237 for the CN stretching. From those comparisons, the samples are most likely PP, PA, or PAN, or with hints of the 3 in each. And the results also correspond to a study by Vianello and colleagues in 2019 about the human exposure to microplastics. They found most of their samples to be fibers and fragments, and they have predominantly figured the microplastics to be out of polyester, but also from nylon and polypropylene. Now for the sources of these microplastics. Nylon is prevalent in indoor fabrics. Polypropylene are fibrous microplastics which are frequently detected in the air to be mostly composed of polypropylene and polyethylene terephthalate. As for polyacrylonitrile, these are commonly used as fibers in the textile industry such as clothing and furnishings. To emphasize the significance of this study, so this study targets on 3 SDGs. First, SDG 3 on good health and well-being. So suspected microplastics can adhere to the human skin. So further study on their health effects, especially from inhalation and thermal contact, should be included in future studies. Next, we have SDG 12, responsible consumption and production. So Philippines was recently ranked first in the plastic polluter in the oceans in 2023. And this study raises awareness for both consumers and producers. And lastly, SDG 15, life on land. The findings of microplastics, shapes, colors, size distribution, explain their sources and how these microplastics can behave in the environment. To conclude this study, there have been possible microplastics detected in the air of Metro Manila through their deposition and thermal contact on the jeepney drivers. An average count of possible microplastics per week were found to be 26 counts from face and 20 counts from neck, and the total average of 92 possible microplastics were both sample sources in all weeks. Majority of the samples were measured to be fine particles, which were less than 100 micrometer, and most of them were identified to be fibrous microplastics. They appeared blue and red mostly. This was followed by the identification of the suspected microplastics as fragments, which was 25%, and the FTIR results suggest the close relation of the microplastics to be nylon, polypropylene, and polyacrylonitrile.
For further recommendations, the study suggests to emphasize methods tailored for airborne microplastics, focusing on particle collection and detection using devices capable of capturing fine airborne particles. In SEM analysis, proper sample preparation, including minimal coating with gold or platinum, is essential for detailed morphological characterization of microplastics. The use of SEM EDX is recommended for both imaging and material identification. For ATR FTIR analysis, micro FTIR is advised for microplastics between 20 micrometer and 1 millimeter due to its enhanced resolution. Lastly, future research could extend to study microplastics in human organs to assess potential health impacts. Thank you for taking time to listen to this presentation.